Alrighty, so welcome to day 11, which means that we have reviewed, we took our little quiz, so day 11 is in day 11 total. We're going to do some factoring today. So if you are in my classroom watching this video, please check the board and vote if you have not already voted, because depending on how the class votes, I'll probably lean towards that method more than one or the other. However, if you're in the video, I'm going to try to do a little bit of both, so that way both types of learners are able to succeed and see examples. So now I'm not going to do every single problem twice, but just be aware that I will do some house and some T-method factoring today. So before we get into that, we're going to do basic factoring, so factoring without numbers in front of my x. So we start by asking, do I have numbers in front of the x squared? No. Cool. Great. Let's go ahead and go on. So when I don't have numbers in front of that x squared, I go ahead and do my two sets of parentheses. Because remember, we're going to undo my FOIL. So we're going to look like a foiling problem before we actually FOIL. So then we ask ourselves, what's the only way to get to x squared? What things multiply together give me x squared? You've guessed it, x times x. So that first part in each parenthesis will be x and x. Now, we're going to see what multiplies to my last number and adds to that middle number. So something that I'm not sure if we talked about last year, if you notice, I have a positive in the back and a negative in the middle. So the only way to get to a positive is either two positives or two negatives, because if you recall your multiplying skills, negative times negative gives you positive, positive times positive gives you negative. Well, if I need to add to a negative number, can two positive numbers magically get me a negative answer? Can you magically have can you get money twice, but then somehow lose it? No. So I'm going to put both signs there negative, because, again, negative times negative gives me that positive. Next thing is I want to think of what multiplies into 6. What are my factors of 6? Well, we got 1 and 6. We got 2 and 3. Will negative 1 minus 6 give me negative 5? No, it will not. It gives me negative 7. Does negative 2 minus 3 give me negative 5? You're correct. It does. So I'm going to have x minus 2 and x minus 3 be my values in my sets of parentheses. The second one, I look to see, do I have any numbers in front of my x squared? I do not, so I go ahead and start with my two sets of parentheses. X times x is the only thing to give me x squared. I notice I have a plus at the end and a minus in the middle, so I have minus minus. Okay, what goes into 28 that adds to 11? Well, I've got 1 and 28, 2 and 14, 4 and 7. Wait a minute. Negative 4 minus 7 gives me that negative 11 I'm looking for. Negative 4 times negative 7 gives me that positive 28. Therefore, my answer must be x minus 4, x minus 7. Okay, I want you to try these next two on your own. When you come back, check your answer. If it is the same, then I want you to skip the next two problems and go into house/T method factoring. If you do not get the exact same answers, I want you to stick around for the explanation of the next two. So either way, I'll see you in a couple seconds. Okay, we are back, which means that we are checking to see our answers. Your first one, you should get x minus 2 times x minus 4. Your second one, you should get x plus 1 times x plus 10. The reason these are both positive is because that last number was a positive, and that middle number was a positive. So the only way to get to both positives is two positive numbers. So again, if you got those two, great. Fast forward my video. If not, stick around. Alrighty, so we're going to take a look at this next example. I have x squared minus x minus 90. Now on your notes, you have x squared minus x plus 90. That is a typing error. Please change that to a minus 90. That was my fault. I forgot to fix it, and I apologize. So, that being said, I'm going to start with my two sets of parentheses again, because I do not have any numbers in front of my x squareds yet. The only thing that multiplies into x squared is x times x. And I want to think of some numbers that multiply into, sorry, I needed some room there, that multiply into negative 90, but add to a negative 1. So I've got negative 90. Okay, let's think logically here, because I'm trying to get you guys to think smarter, not harder. I have 1 and 90 that multiply into regular positive 90, right? And then one variation of the other. Is that somehow going to give me anywhere close to a negative 1? No. So when I'm looking for some of these numbers, I want to think about what number I'm going to add to help me narrow down my search. So if I want to get to a negative 1 or a positive 1, that means my values are very close to each other. They're only one number away. So do you know any two numbers that multiply into 90 that are only one number away from each other? Yeah, 9 and 10. Because 9 times 10 gives me that 90. Now this is the part that we need to really work on. I want to get to negative 1. So do I want negative 9 plus 10? Or do I want 9 minus 10? We want that minus 10 because 9 minus 10 gives me that negative 1. So my answer here is going to be x minus 10, x plus 9. All right, second one. Again, no number in front of that x squared, so I can start with doing my two sets of parentheses. X is in front. This one's a little bit different. We have one minus in the back, and we're going to add to a positive. So if you notice the example before, we had negative and negative. Well, the only way to multiply to that negative is one negative, one positive. And in this case, because I got two negatives, my bigger number ended up with the negative sign. Well, we're going to have one negative, one positive. But my bigger number is going to end up positive. The reason being is because I'm going to take a number minus a smaller number and still be positive. Okay, so let's take a look again at what goes into 18. How about 6 and 3? Is that what we're coming up with? Okay, again, I want one positive, one negative. So do I want negative 6 plus 3 or 6 minus 3? Yeah, 6 minus 3, because 6 minus 3 gives me positive 3. So I'm going to have x minus 6. I'm going to have x, excuse me, I said what I wanted and then wrote the wrong thing. I'm sorry, guys. So I'm going to have x minus 3 and x plus 6. Because again, 6 being that bigger is going to have that positive value. Alrighty, if you were able to get past those first two examples on that last slide, welcome back. If you just watched those last two examples with me, thanks for staying with me. So we're going to do this first one as house method. And then that means I'm going to use this one as T method. I'm going to write that so I don't forget. Again, I'm not really sure who all is watching, so I have to at least try and get each example once. So on house method, I know I have a nice sunny day, and in my nice sunny day I have the multiplication of 2 times 4, which gives me a nice lovely 8. On my nice sunny day, I get close to my house. My house has some windows, which is my parentheses. My windows need some blinds. So I gotta think what first multiplies into 2x squared. Well, we know that x squared is equal to x times x. But what about 2? What two numbers multiply into 2? Yeah, 2 times 1. So I'm going to have a 2x and a 1x, or just plain x. Now I have to use my son and figure out, all right, son, what two numbers multiply into 8 but add to give me 6? 2 and 4. Good job. And again, positive, so they're going to be both plus here in the middle. So what I need to do is my plumbing of my house. I got my 2 and my 4. Now, 2 different ways to approach this house problem, so bear with me here. My 2 here, a green 2, I want a factor of 2. Well, I already have a red 2 there already. So I'm going to take that green 2 divided by that red 2. I'm going to get a positive 1. I just need a single factor of 2. I've already got a red 1, so my purple 1 is not going to be there. I'm going to divide it out. Then when I do the rest of my plumbing, I don't have a number in front of my x, the second x, to divide out, so I'm just going to have plus 4. Or, if I go back and start this the exact same way, I have that 2x and that x. Say I put my 4 on top and my 2 on bottom. Well, I can take 4 divided by 2 and get plus 2. My x here, nothing divides out. I get plus 2. So there's 2 different potential answers for this one. Now, there are going to be examples like this that are similar. They're different, but they're still the same. If you don't believe me, pause the video, FOIL out those 2 examples, or excuse me, FOIL out those 2 answers and see if you get the exact same answer. Some of these, it's hard to, neither one is better than the other. They'll get you the exact same answer. So you could be doing house method with a friend, and depending on which you divide by first, you could have 2 different answers, both still right. So if you guys question, make sure you just talk to me and we'll chat about it. All right. The second one, I told you I was going to do T method. Okay, what's going on? Thank you. So in T method, I have a big giant capital T off to the side. On my big capital T is going to be the multiplication of 7 times negative 21. Which I believe is negative 147, but I have misplaced my answer key, so I'm just going to double check. Yep, so it's going to give me negative 147. That looks like an L. I'm sorry, let me fix that real quick for you guys. All right, so what 2 numbers multiply into negative 147 but add to negative 14? Now, here's a nice little trick that I like to use. When I get big numbers like this, like 147, that's pretty big, I ask myself, can I somehow use the numbers I just multiplied to add to that middle number? So can I somehow use 7 and 21? Now think, if I've got a negative and a negative, I want the bigger negative number. So humor me here and take 7 minus 21 for me. Did you get negative 14? Okay, so when I come to examples like this, I want to try and see, hey, sometimes whatever 2 numbers I multiplied together, that's actually going to also be whatever I add to, the 2 numbers that I add to. If you take a look at the house method one, it was the same way. All right, so when I do T method, I'm going to write my first term the same. So I have 7x squared. I'm going to replace the 14x with the two numbers that I just found. Now when I do this, I want to try and keep same numbers together or same signs together or numbers that multiply into each other. So 7 goes into both 7 and 21, but I want my positive 7 here so I don't have to deal with some sign issues. So I'm going to have plus 7x minus 21x minus 21. Now I'm going to do what's called that factoring by grouping. I'm going to take a look at the first two terms and see what can I factor out of those. Well, I can take out a 7, and I can take out an, oops, premature parenthesis there. I can take out a 7, and I can take out an x. So what am I left when I divide that out? Well, when I take 7 out of 7, I'm left with 1. When I take x out of x squared, I'm left with just plain x. Well, I'm dividing 7x out of 7x, that's left with just plus 1. Alright, I'm going to leave a little space, and I'm going to write the exact same thing I just saw in those parentheses again. This is the whole point of t-factoring. This is why it's nice and easy, because I really only have to do hard factoring once. Now I want to take a look at my last two terms, my negative 21x and my negative 21, and see what did I factor out to get to x plus 1. Well, I didn't factor out an x because I only have one x to work with, but I did factor out negative 21, because if I multiply that negative 21 back into x, I'd get that negative 21x. My last little step here, my answer will be one of the copied group, because you know I had to take that x plus 1 and copy it over. And then the other will be the 7x together with the negative 21. And that's going to be my answer. So again, two different types of factoring with numbers in front. Neither is more correct than the other. It is whichever you prefer to do. But remember, you need to pick one that works for you and stick with it. I will be going back and forth, so just check your answers. Now again, say you like T-method and you did that first one T-method. Remember how I said there's two different ways to do it? You can have a couple different answers. It'll still get to the same thing in the end. All right. Let's take a look at what we have in these two. What do you notice different about these two compared to the last two we just did? This time they're set equal to 0. So once we figure out my grouping or my factors, I have to pull each factor apart and set equal to 0. I promise it'll be okay. We'll get there a step at a time. So I'm going to do house over here again. So my nice sunny day, I have negative 24. I want to think about what goes into negative 24 that adds to positive 5. So I'm going to have a negative and a positive. In this case, my 2 and my 12 didn't work. Next, I think of 4 and 6. Well, that's not going to work. What about 8 and 3? Can I take 8 minus 3 and get 5? Sweet! Okay, so I have my 2x and my x. I have my 8 and my negative 3. 2 cannot divide into negative 3. I can't take negative 3 divided by 2. So I'm going to take my negative 2 and divide it from my 8. So I'm going to have plus 4. Nothing in front of that second x, so I have minus 3. So my two sets of parentheses are 2x minus 3 and x plus 4. Now think about it. I have this set equal to 0. When I'm dealing with multiplication, what is the only way to get an answer of 0? 0 times anything, correct? So that's saying that either this first group here is equal to 0, or this last group is equal to 0, or they're both 0. So now that I have these multiplied together, I can pull them apart and set each one equal to 0. Why do I want to do this? This helps me find my x values now. So say I were to graph, or I was looking at this as a physics example. No, we're not going to look at physics examples, but this is why we use factoring. So I add over that 3. I get 2x is equal to 3. Divided by 2, x is equal to 3 over 2, or 1.5. Subtract that 4. I get x is equal to -4. So I have 2 answers on this. Okay, since I did house over here, I'm going to do t on this one. So I have my big capital T. Multiply into 5 and 1. 5 times 1 is 5. Okay, so what gets me to 6? Well, 5 and 1. So I have that 5x squared plus 5x plus 1x plus 1. Purple, I didn't use that one. So what divides out of these two? I can take out a 5 and I can take out an x. I'm left with x plus 1. Leave that nice little space and write x plus 1 again. Alright, taking a look at that last two, is there any change between what I see in red versus what's below in purple? No. So when I have this exact same thing before I factor, I'm going to say I'm taking out a plus 1. I factored out 1. Because when you take 1 divided by 1, it's still 1. The reason I have to do that is so I have that second set of parentheses. Because remember, we said my answer is going to be one set of the factored group, of the copied group, and the other is going to be what's left over. Well, if I don't have anything in that little spot, I don't have that little extra leftover part, so therefore I can't find my answer. So if it's ever the same, it'll just be plus 1. So I can go ahead and stick my two sets together. Just like I did on the problem to the left, now that they're being multiplied, I can pull them apart and set them both equal to 0. Solve for x. X is equal to -1. Or x is equal to -1/5. So if you guys can't tell, my air conditioner just kicked on. I'm going to try and finish this video, see how it sounds. If it doesn't sound very good, I will not record with it on. But I think we're almost done with this, so I don't want to just stop now. So let's see if there's one more. Nope, that's it. All right. I will see you guys tomorrow. Again, if you have questions, please, please, please come and ask me.